Hi everyone, Mrs. Jones here. In this video, I am going to explain to you how we can use all the different ways that we know of solving systems and apply them to scenarios. So keep in mind that you know about systems as being when more than one equation is working together with more than one variable. And we have learned three ways to solve systems. You've learned about graphing them and finding their intersection point or points. There can be more than one, and that's the solution. You've learned about substitution, so literally taking one equation and substituting or plugging it into the other. And you've learned about elimination and being able to add or subtract equations in order to then eliminate a variable, solve for one variable, and then go back and figure out the other one. So we're going to keep all of that in mind as we try to solve some scenario. So for all the Justin Bieber fans out there, here's a word problem for you. It says Elizabeth is going to a Justin Bieber concert. Awesome. And she knows that 2,200 people are going to be there, including her. Kid tickets cost $3 and adult tickets cost $5. Those are fantastic prices. And she knows that they raised $9,600 total. How many kids are going to be at the Justin Bieber concert? So, the first thing that we need to do is we need to define our unknowns, meaning what information here is missing, and we need to represent that with a variable. So, the two things that are missing here are going to be represented by x and y, and we are going to define x as being the number of kids at the concert. Okay, a really good hint is that the question always gives you a clue, or 99% of the time gives you a clue as to what information is missing and how to represent your variables. So the number of kids we don't know. The other thing that we don't know is the number of adults. Now I am choosing to use the letters X and Y, but if you wanted to use the variable K to represent the number of kids and the variable A to represent the number of adults, that is totally fine. Up to you. All right, now with a system, we need more than one equation. So we're going to start with two and make sure that covers all of our information. So the first equation we are going to write is going to involve this first sentence here, or I guess rather third sentence, that says that she knows that 2,200 people are going to be at the concert. So that tells me that I can take the number of adults plus the number of, the number of kids plus the number of adults and say that that's going to be equal to 2,200. I can then take my next piece of information that tells me how much the tickets cost and the total money raised. I know that every kid is going to be charged $3. And I know that every adult is going to be charged $5, which gave me a total of $9,600. I now have my system. I have two equations and I have two variables. And in this situation, hopefully you recognize that we have two linear equations. So this is going to be linear system. So we're going to look for one solution, hopefully. All right, here we go. I'm going to decide to solve this using elimination. So I'm going to multiply my top equation by 3, which is going to result in a new equation of 3x plus 3y equals 6,600. I'm then going to rewrite my bottom equation, and then I'm going to subtract. And I'm choosing to subtract here because when I do that, my x's will cancel out. Remember, when we eliminate, we're looking for the same coefficient. So when that happens, I'm going to be left with negative 2y equals negative 3,000. I can then solve for y by dividing by negative 2 on both sides, and that's going to tell me y equals 1,500. So I know that there are 1,500 adults at the concert. Now I need to go find the number of kids at the concert. And the way that I can do that is I could use any one of the equations that I have already written. But I want to be most efficient. I really like efficiency. And so I'm going to choose to use my green equation because that seems to be the simplest. And I'm going to plug in 1,500 for y. I then want to solve for x. So I'm going to subtract 1,500 on both sides. And that's going to tell me that x equals 700. So I have now solved and discovered that there were 700 kids at the concert. Hopefully this one makes sense. We're going to try another one. I have already done this problem and I'm going to reveal my work under the boxes, but I first want you to pause and I want you to try this equation or this system on your own. So pause now, try to solve the whole thing. You can either choose to use substitution or elimination, it doesn't matter. And then we'll come back and see if we agree. All right, you're back. So under the first box is going to be my definition of variables and my system. So I, in this situation, decided to use L and C to represent the lollipops and the cookies. And I wrote my equation as being L plus C to represent the 50 total items. And I wrote my other equation as L plus 2C equals 80 to represent the $80 that Teddy made. So I, in this situation, actually chose to use substitution just to show you another example. So I decided to take the bottom equation here. I chose to take this equation and I rewrote it as this green equation, meaning I just subtracted 2C from both sides. I then plugged that into the top equation. So my new equation with the substitution became 80 minus 2C plus C equals 50. When I solved this all the way down, I ended up with C equals 30. I then took that C equals 30 and I plugged it into the top equation to solve for 20 as L. So Teddy sold 30 cookies and he sold 20 lollipops. All right, we're going to try one more problem together. I want to do this last problem together because there's a couple different ways of solving it. And again, I want to show you what I think might be most efficient. So it says Sam mowed his neighbor's lawn for a handful of dimes and nickels. He counted 80 coins in total. Upon completing the job, he counted out the coins and it came to $6.60. How many of each coin did he earn? So remember what I said, we always want to look at this question to give us clues as to what we do not know. And what we don't know is the number of dimes and the number of nickels. So I'm going to write D as being the number of dimes, and I'm going to write N as being the number of nickels. Now, I am going to write my two equations. My first equation is going to have to do with the fact that he has 80 coins. So I'm going to say D plus N equals 80. My next equation, there are two different ways of writing this. One way we could write this is we could write it as 0.010, because I know a dime is 10 cents, plus 0.05, because I know a nickel is 5 cents, equals $6.60. Okay, now this whole equation here is all written in terms of money, and there's lots of decimals. But what if I actually wanted to write everything in terms of cents? Because that would get rid of my decimals. So you could also write this second equation as 10D, because 10 cents for a dime, plus 5N, because I have 5 cents for a nickel, equals, now my $6.60, I want to write that all in terms of cents. So I know that's going to be a total of 660 cents. So when you are using, or when you're solving a question like this that has to do with money, you can choose to either work in dollars or cents. You just need to be consistent all the way through your equation. If I were you, I prefer to work without the decimals, so I actually prefer the cent equation. So I would solve this one using the system of D plus N equals 80, and then 10D plus 5N equals 660. Again, you could choose to either use substitution or elimination, but I'm sure you can take it from here. So hopefully this helps. You have a few systems word problems to try now on your own, and let us know if you have any questions. Good luck.